between this router 1 and 2 we got 3 paths, via router 3, via router 4, via router 5. Any of this path you can take. But we want to test unequal cost load balancing. Right now all the metrics are same in these links, so it's not going to take any of this path. It takes all of this path, all this path. It does load sharing, a kind of flow based load sharing via all these 3. It does sharing load via all these 3. We will make it unequal by using variance or bandwidth. Maybe I'll go and increase the delay here. I'll increase the delay here so that this will be seen as a low priority path, and only these 2 will be there in the routing table. Then what I'll do, I'll go and this here I increase the delay. Now here I'll decrease the bandwidth so that this will also be seen as low priority path, and the only route will be available is via router 3. After that we'll see whether these routes are available as a feasible successor. See, further it needs to satisfy the feasibility condition. After I change the delay, the advertised distance must be less than the successor value. This is the successor's value. If it is not, then it won't be there in the topology table. If it is not in the topology table, it will not be used for load balancing, even if you change the variance. First thing is, I need the feasible successor in the topology table. Only then that feasibility condition is met and loop free backup path is installed into the topology table. Let's see. Let's do one by one. So to reach this 2.2.2.2 destination, this is the feasible distance. What is feasible distance? The total metric of the successor route. Because all 3 are successor now, when the variance is 1, if all 3 are successor, so definitely the total distance will also be same, because the variance is 1. Successor multiplied by 1 is same. So the other routes, if they need to be a successor, they need to have same number. They are having same number. It can go via 5, 4, 3. Now this is unequal. This is equal cost path. Not a big deal. By default it can do up to 4 routes. In topology table, show IP Eigrp topology, you have the similar information. Feasible distance for 2.2.2.2 via router 3 is this, and it will also show you advertised distance. So this page is more important than the routing table for us to understand this topic, because for feasibility condition the advertised distance should be less than the successor value, no? So first we will make it as unequal, and then we'll come back and see, and we'll move further later. So I'm going to go to the link between R3 and R4 and R2. I'll go to this link and change the delay value. The current delay I want to show you first. The current delay show interface G0/1. You see, the current delay is shown there. This is the current delay. Let's change this. Interface G0/1 delay tenths of microsecond. Is it tenths of microsecond here? Yes. I'm going to do what? I'm going to increase the delay. Let me try to increase to 11 and see what happens. Going back to the interface G00, I've changed to, oh, it has become 110, which means it is multiplying by 100. It's multiplying by 100. Earlier it was 10. I just made the 11 and it has become 110. So I should not say 11. I will make it little small. Or let us go and check whether we see still this one in the topology table. Sometimes that may not satisfy the feasibility condition. You see, gone. It didn't satisfy the feasibility condition via 4. So it is not seen, only 2 successors. So let me go and tune a little bit more, smaller number. I'll say delay as not 11. Let me see 2 and see what happens. It should show 20 now. Yeah, 20. Good. As we expected, so it was multiplying by 10 tenths of microsecond, so it is 20. Earlier it was 10, now it is 20. 20. All others are having 10, only this link has got 20. Let's see whether now, even now it didn't satisfy the feasibility condition, because the 20 itself is bigger. It's too big, it didn't satisfy the feasibility condition. Let me go and try changing something in which I don't think there is a possibility to give a fraction number. Not allowed. So what's the way? There should be some way. Let's focus then on bandwidth. I'm cancelling the delay. Alright, 6 times 9.
Okay.
6 times 9. So now let's go and check on R1. Yes, no. That didn't make any big difference. So let's make some
800 MB, sir.
No, that will be too low. Let's make this zeros. Now gone. So this itself it is not accepting. So let us make little bigger. So 9. Yes, but that didn't make any big difference here. I'll put the same on the other end, on router 2G01. See, the issue is the composite metric. This is also multiplying and then dividing with 10 to the power of 7 and so on. That's why it makes big difference when I do small changes. I put this on both sides and see whether anything turns up. Not it's not shown as it's not showing anything now. So but why when I put 0 here it didn't come? Let's wait for some time. I think when you wait sometime it will come. It shows 2 paths. Give some time. Topology 2.2.2.2 /32. Not in a brief. It's okay. No, completely gone. When I put 998, so instead of tuning like this, we'll consider any one metric. Because it is bandwidth and delay and the algorithm, it's confusing. It's taking time to find out the number. So I'm going to go to all the router and tell Eigrp to focus only on delay or focus only on bandwidth. You see, show IP protocol. Right now it is focusing on both bandwidth and delay. If I want only delay, I'll put 0 here. So this only will have 1. How to do this? But when you do this, it's better to do in a notepad and copy and paste. The reason is it needs to be done faster. Router Eigrp. What is the autonomous system number I gave? Autonomous system number 333. See, this is the command. Metric wait. And then just put 0 here, but we don't have any QoS type. K1, do you want to consider bandwidth? No. K2, do you want to consider load? No. K3, do you want to consider delay? Yes. K4, I don't want to consider reliability. I don't want to consider MTU. That's all. This you need to paste it on every router, but as soon as you hit enter here, it will start throwing errors from other. So better you put it in a notepad quickly. Enable router Eigrp 333. Paste this. Don't hit enter. We'll paste this on all the router, and then we'll hit enter. Router 1, router 2, router 3, router 4, and router 5. Okay, I think I hit enter on every router. Otherwise it will say this K value mismatch. You should not see that error message K value mismatch. Yeah, I believe I have given on all the routers. Now if you go and check, the topology table will have small number. Show IP Eigrp topology. You will not see that big number Do we still have the big number? Earlier it was what? Is this the number? Right now I said focus only on show IP, Eigrp, show IP protocol. Yeah, it focuses only on the delay now. So you need to tune only delay. Yes, 333. Okay. So delay is sum of delay. Delay is sum of delay. It will add delays. It will add the delays on all the links, all three links in the path. See, the delay between the gateway to the destination is this. So what will be the delay between the router 1 and the gateway? You need to subtract, right? If you subtract, you will know the delay. So I'm going to use the calculator. I think it is 256 underneath the 256. 128 512 minus the advertised distance, advertised to delay, 128 256, which is equal to 256. That's it. So the delay on each link is 256. On router 4, let's change the delay. Do show run interface G0/1. What delay it shows here? Sorry, not run. Yeah, 256 only this shows, right? No, this is what this is confusing with that. That's Eigrp delay. Interface G0/1. Fine, we have changed the interface delay on all the interface including the loopback as 5. As a result, the interface shows like this. Show interface G0/1. It shows 50. It shows 50. Let us now make one route as the best route by decreasing the delay. I'll go to router 3 and decrease the delay to 4. Interface G0/1, delay is 4. So this becomes 40. Now when I go to router 1, I see only one successor because the advertised distance of the first path is lesser than the other two. So now we will have only one route in the routing table. See, show IP route. Only one route, that is via router 3. We lost the route via router 4 and 5. So what should we do? We should increase the variance. Please focus. It's a very nice output. Topology. You see, because the advertised distance of the other routes are less than the FD value, this is the FD value, feasible distance value. Why it is 2186? Yeah, feasible distance value. Because these are less than the FD value, They are seen in the topology table. Right? If I'll go and make this as 6, that may disappear. Okay, so let's not get into that. Now, if I multiply it by this by 2, the variance will become 4000 change. So any total distance less than 4000 change should be considered. Right now only one successor, right? See, I'm going to change the variance. Router Eigrp 333 variance 2. Now you will see 3 successor. Let's see. Show IP Eigrp topology. Look at this. You got 3 successor. Why? Because I changed the variance. When I change the variance, this number will be multiplied by that variance number 2, and an answer you receive, right? 4000 or 5000 something. All roots that is less than that multiplied value. So this is less, this is less. So 3 successor. Now you will see 3 routes in the routing table. Show IP route Eigrp. Even though the costs are unequal, see these 2 are high than this. Even though the costs are unequal, Eigrp can do load sharing according to the capacity. This can do load sharing. Right, that's what we learned in the variance unequal cost load balancing page. It took some time for figuring out the number to decrease, increase. What I have done so far is I have changed the metric weight to consider only delay, not the bandwidth. Later, like our Girish said, what we did is we went to all the router and we just fixed our own delay. We made it as 5. And then to make one route better than the other, we went to router 3 here on G01. We give delay as 4, only on that router 4. Other routers are having 5. So when you have 4, this is the metric via router 3. This was the only route that was shown when variance was not configured. When I configured variance, the FD value was multiplied by variance, and these numbers were less than, these numbers are less than the multiplied value. So they are seen in the topology table as well as the routing table as successor routes. One more time, I'll remove the variance and show you. When I remove the variance, you will get only one route. See? I remove the variance. In the routing table now, show IP route Eigrp, you will have only one route. See, only one route. But when I put the variance, you get 3 routes. So variance is the command that is making Eigrp to support this unequal cost load balancing. See, we spend a lot of time to make paths unequal. In the real world, you will have naturally unequal cost paths. So you will not spend this much time. All that you need to spend is time on configuring variance. Just you go under router Eigrp, put the variance, boom, finish. You get the result. Yeah. So just variance is the key that you learn from here to do unequal cost load balancing. Nothing wrong, nothing more. All other things that we did is for simulating some real world unequal cost path. So